Before going into the mass production of the any product, simulation is paramount for the effectiveness of the design. Simulation provides invaluable insight about cost effectiveness, risk management, optimization, and complexity of the systems. Even though there is lots of software available in the market, ANSYS stand out among them. It's not only compatible, but also it has a prominent history with better result. Now we are going to see one of the simulation with ANSYS. So here's the interface of the ANSYS. It's called Workbench. As you can see here, there's lots of tools available. But for today, we are going to test Tensile string. So for that, we have to drag this explicit dynamics here in the project scheme. Then we can see there is lots of options showing here. First option is engineering data. Basically, we have to define the material here. So let me go to the engineering data. As you can see here, there is only one material is selected, and that is steel. So if we want to change the materials, we have to go to the engineering data source. For now, we are going to select the explicit material. This material is good for simulations. These show accurate simulations. And in the explicit material, there is lots of options available here. So for now, we are going to select the aluminum 1100 O, and we can see here there is a plus icon is showing. We have to click here. And after selecting the aluminum, let's get back to the previous step. So as you can see, there's two materials showing. So we don't need two materials. So for that, we have to select the steel. So we can select the steel. Let's get back to the project tab. As you can see, there is a green icon is showing here. That means the engineering data is selected. Then going to then we can see here there is a geometry. So we have to have existing design of a product, or we can design it from here. But for now, I have an existing design. So I designed it in SolidWorks. So we can import the design. In the import geometry, we can see here there is TS, which is tensile strength. So geometry is selected. The green icon is showing. After that, we have to select the model sections, and we have to give some property to the model sections. So for that, we have to double click the model. It requires some time to open. This depends on your PC's computer's specifications. After opening the model section, so as you can see, the model is showing on the right hand side, and there are some options on the left hand side. So we have to define the options. We have to preset those options before making any solutions. So first of all, in the geometry sections, we have to define the material. So in the geometry section, there is lots of options, but we have to manually and must be define the material section in the assignment. So we have assigned the aluminum. After that, the coordination system is checked here. The mesh size, we can increase or decrease the mesh size here, but right now we leave it like that. And then the analysis sections, we have to define the end time. So for right now 0.001. After that, we have to insert the displacement and also insert the fixed support. So for fixed support, which phase we have to fix the which phase we have to fix. So we have to define it. For right now, select the fixed phases here and then apply. So this is our fixed positions, and then the displacement. For displacement, we have to select these phases and click apply. So as you can see here, the x coordination is showing clearly here. So we have to displace it in the reverse x direction. For now, for that, we have to put minus 0.25 meters. Then in solution sections, we have to insert the deformations, strain, and also stress. So this solution we want to get. So after giving all the requirement, we can select solve. So for solving the simulations, it requires some time, and it depends on our computer's ability and specifications. So it requires some time. After simulation, we can see the total deformation, stress, and strain. If we click animations, see here the animation is showing. and in the strain sections you can see the animation is also showing. So if we want to see the maximum deformations or maximum stress strength, so in the deformation sections we have to click the maximum point. Here is the maximum point. This is the maximum deformations, and maximum deformation is showing here. This is the maximum deformations, 0.250119. And if you want to see the minimum deformations, you can select the minimum key here. And the minimum deformation is will occur in here, this point, which is 0. The maximum deformation occur in this point. So this is how ANSYS is all about. Also stress, strain, also like maximum strain occur in this point, minimum is this point. So and also stress is occurring in this point, and minimum stress occur in this point. This is how we can simulate any kind of mechanical property with the help of ANSYS. It's very much convenient, easy, and it gives proper and precise value. Hope you understand. Thank you.